G'day, my name's Pete DeVoyle. I'm here today to talk to you about crop rotations in AppSim Classic. Let's see how we go. Okay, so a bit of history first, how we got to where we are. When we first built AppSim, we had this idea of manager components that manage crops. And we realised that we could make crop rotations very quickly and simply if we just put in multiple managers. If we had like a wheat manager that looked after a wheat crop manager and a summer manager like a sorghum manager that would look after the sorghum manager in summer. Because they wouldn't both try and plant the crops at the same time, they could coexist quite well and quite simply. It was a simple way around it. We extended this with a little bit of work to cater for things like Longfellows by using the operations module, which would let us form a calendar of operation, a sequence of events that went from the top to the bottom. That was also quite useful because it just let us specify when what crops were going to happen in what order. But we soon realised that we really wanted to think about some of the dynamic nature of farm management, and we needed to represent some way of the decisions that are being made at any one time. And we came up with this idea of a state transition network or a bubble chart that was able to represent the decisions that are made at different points in time in the crop rotation calendar. We liked this idea because it gave us a really flexible model that wasn't just crop rotations, but it could also be used for things like moving animals around on farm. It could be used for irrigating water and transferring water between storages, etc. There was a lot that it could be used for to add complex decision logic into AppSim quite simply. So there's a sample in AppSim. If you just go to the new simulation button and you try and find the rotation sample here, you'll see it opens up just as any other. There's nothing fancy here, but what you do notice straight away is that there are two crops in the simulation. There's a chickpea crop, there's a wheat crop, and there's also a whole bunch more managers than we're used to having. Normally, for a monoculture simulation, we might only have one manager, but here we've got at least half a dozen. And they all do different things. We'll see that there's this bubble chart that I was talking about at the top of the simulation. It's going to coordinate the other managers in the system. It's going to coordinate when to plant a chickpea crop and when to plant a wheat crop. When I say it coordinates, it doesn't do anything to the wheat and chickpea crop itself. It's really dumb. It only knows that there are other managers that can do that thing for it. And so there's a chickpea management component that talks about the things that you need to know about to plant a chickpea crop. And likewise, there's a wheat management component that talks about the things you need to go to a wheat crop as well too. A whole bunch of others. There's a couple of helpers here as well that make life easy for reporting. And you'll see that the reporting in these sorts of simulations actually gets quite complex, and quite often we have more than one or two files as outputs. We quite often use harvest reports that are useful for reporting harvest yields of crops, and we also have these phase reports that report the conditions during each phase of the crop rotation. These are really useful for seeing a top-down perspective of what's going on in your system. And if you're really stuck, you might even have some daily outputs that you have to manipulate as well too, but you'll see that they get quite large and cumbersome. Anyway, that's the major components in these simulations here. We've talked about them there. Yeah. We talk about the new component here. So it's built around this idea of having nodes and arcs that connect the nodes. You can have more than one arc that would connect a node, and we do this by working on the bubble chart at the top. There's a little context sensitive menu here that changes according to what's selected on the top there, and it says left click, you select a node or an arc. Right click will pop up as a menu, and once you've selected it, then you can drag it and move it around on the chart. You create a new node by right-clicking on the blank area, and then you create arcs by clicking on the source and then the destination. We'll go through that now. So if you click on the blank area of the chart with the right mouse button, you'll get in a menu that says Add a State, and so that'll add a new chart node state to the chart. You can then go off and configure it, give it a new name. You can also change its color and give it a description. You know, the usual things that you'd expect in these sorts of things. You can put it pretty much wherever you like. There's no restrictions on layout. It's up to you to make it look pretty. You'll see that you can pop up on a menu by right-clicking on that node. It'll give you something that's context sensitive to that node, delete, duplicate, etc., etc. When you want to make an arc or a transition pathway, you've got to click on the source of where you're wanting to begin, and then right-click on the destination, and you get this menu that says Add Arc from the source to the destination. And once you've made that destination arc, you can then move things around and play with them to your heart's content. Okay, you'll see that the menus for nodes are fairly basic, just their name and the colors. Okay, the arcs start to get a little bit more complicated, and they talk about these rules and actions. And these rules and actions are the fundamental component, a fundamental idea that make this system work. Rules are variables in AppSim. They're states that we can interrogate, and actions are events that happen during the course of the simulation. We'll come back to that later on as to how we get there. But also, while we're here on this page here, you'll see that there's some administration here. We want to say if we've got a multi-paddock simulation, it says which paddocks does this particular state chart manage. It also says where does this simulation start and which state does it start, because it's got to be somewhere. And it also says down here, keep a detailed event log of everything that happens if you want it. These detailed event logs can get rather large, so you may not want to run them on every simulation. On the right-hand side, we've got the same component that we use in the report component that lists all the variables and events in the system. You select the different modules in the system on here. Once you've done that, you should get up a list of variables by default. It says here's a variable called canEnter, and it's a test as to whether we can sow a crop today. So the variables are no different from the variables that you've been putting in report files, much like a biomass of a crop or the days after sowing. But the only difference is we only care if it's a 1 or a 0. So typically the ones that are interesting to us are from manager components. Can it enter the component, and can it enter the state that wheat management component is managing today, and can it leave that state, etc. You'll see that also that menu changes and also pops up the events that module is listening out for, and that'll be useful later when we talk about transitions between states. Anyway, back here on. By itself, these crop manager components are very dumb. There's only about 20 or 30 lines of code in them, and they rely on being able to talk to the other manager components of the system. These other manager components have got specific information about the crops they're managing, and that specific information is different for all of those other crops. Okay, normally when we've got the managed components in the system, they behave independently if we haven't got a sequence that's plugged into the system. So if you've got a continuous wheat simulation, you're going to see that there's no rotation manager. The wheat crop just goes off and does the same thing every year all by itself. Now, if you dropped a rotation manager component into that simulation, that wheat component manager that manages the crop is going to see that there's a coordinator present, and it's going to stop doing things by itself. And then it'll only do what it's told to by the sequencing component. Okay, so this is a behind the scenes sort of look as to how they work together. By themselves, they work by just that. They will work by themselves. When you want to use more, you've got to use more in conjunction. You've got to use something together that will coordinate their behaviour. The operation of the component is actually really simple. It says, can I do something? And if it can't do anything, That's it for the day. It's a really simple operation. It says, when it says, can I do something, it's asking the system to say, what's the value of a variable in the system that lets me do something together. We'll talk about this in terms of like the chickpea crop. So let's say we're in a chickpea crop in the ground, and we're saying, are we ready for harvest? And so the component, the rotation management component is going to ask the chickpea management component whether it can leave that particular state. We've got generic names for these states called enter and leave, and that aren't really operations, okay? They're meant to be generic. When we talk about rules, these are asking whether we can make a transition. We're talking about getting a variable from the system, okay? It's the same as you would write out a variable into a report file. Well, we're doing the same thing, except we're not writing to a report file, we're making a decision on that particular variable. And when we talk about actions, or when we make a transition, we're talking about events that are published to the system. And so this might be like an enter event to a chickpea management component would be to sow the crop and do your thing. Okay, but coming back to how the chickpea, the rotation manager component does its logic every day, it simply says, can I do something? And if it says, yes, I can harvest the crop today, then it goes off and carries out the action that's associated with that leaving that state. And once it's done that action, it goes on to the next state, which will be some sort of a fallow crop. So a little bit more about the nodes. They're abstract. They don't really have to represent a physical state in the systems. That's something like an irrigation component an irrigation state might be useful to you when you're building these nodes. And they can be ephemeral too. They can be left immediately after entry within the same day. They also, they can be partially connected with the entry or exit arcs as well too. If I've got any hints on how to use these is when you're making these nodes, don't use white space in their names. That gets really complicated later on. And also that case is significant. If you've got spelling mistakes or upper and lower case, then that's going to really cause you grief. You should also, when you're setting these up, you should make sure that the starting point of the simulation exists. Otherwise, it's never going to do anything for you. And don't try and start in a crop. You start immediately before the crop is sown. So if you're thinking about an initial state, a fallow state when there's no crop in the ground is a good place to start. If you try and start in a chickpea crop, you can see that what's going to happen is that the AppSim's going to say, is this chickpea ready to harvest? Is this chickpea ready to harvest? It's never going to be ready to harvest because it's never been sown. So always start when there's no crop in the ground. Okay, so about arcs, they must have, of course, source and a destination. And we have this idea of a rule associated with the arcs. Now, when we talked earlier, we had some rules here. If you can manage to click on it and get it right. Man, it's fussy sometimes. So we talk about rules that we're getting from the system, and then what the component does is you can have more than one rule that lets you go through the system. And the way it works out is it says it gets the value of the first rule, which is either a 1 or a 0, and it gets the value of the second rule, which is either a 1 or 0, and multiplies them all together. If any of them are 0, then that rule makes that transition infeasible for that day. If they're all 1 or if they're all positive, then it's a candidate for doing something that day. If you've got the case where there are 2 arcs out of a node that evaluate positive on a particular day, then it's going to take the highest valued one. So you can have like a number inside there, or give it a continuous number that will give you something, one path worth more favorable than another if they're both candidates on the same day. So if I can suggest anything here, if you're talking about manipulating these rules here, use copy and paste wherever you can, because spelling mistakes are really hard to see on that tiny screen down there. Okay. Also, if you're making up these charts, don't start with big complicated charts. Just start with 2 nodes and get them working. Okay, that's really a philosophy for AppSim all over. You make small incremental changes and then test. You know, if you go and build a big complicated chart and then get to the end of it and try and figure out why it's not working, then it's your complexity of solving that is going to be much, much larger than if you just started with a simple chart. Okay, so small and test. Okay, so we talk about the sequencer, its behavior each day. So it goes, we talk about doing this daily process event. It happens on the process, which is not the beginning, not the end, but in the middle. And it sends out 3 events every day when it decides to change state. It sends out an event from a transition from the previous state. It sends out a transition event by itself, and then it sends a transition to, and then the state name that it's changing to. We can use these events as like triggers for the tracker module or for reporting components or whatever. But yeah, those transition events are sent out as it's doing the state transition, obviously. So that's it as in its operation. And let's say, well, it always goes wrong. AppSim goes wrong. So how do we find out what's going on? Well, the summary file is the obvious place to start. If you've made a mistake, it's going to a good chance there's going to be an error message in the summary file. If I can suggest the common mistakes that I make, is did you include a space in a node name? You know, so if you've called it like a chick space P crop, then some weird things are going to happen, and the manager's not going to make much sense to you. Okay, you also it's a good idea to check the output file for inordinately long phases to see whether they've been, something's gone on for several years when you were only expecting a couple of months. Okay, when it goes really wrong, you've got this thing called the detailed log file, which we saw the switch for to turn it on is here on the page. What this does is, this is worth looking at in detail. It writes out every rule in every day. So we go off and you can see here's the simulation going from day 0 to day 1. And we've gotten to the end of a summer fallow state and we're making a transition into a wheat crop. And so on the 26th, it's decided, you know, can it leave the summer fallow component, and the value of that rule is 1, but it says can it enter the wheat component, and the value of that one is 0. So 1 times 0 is 0, which means that's not going to happen that day. The next day it goes off and makes the same evaluation on the 27th, and it says yes, I can leave the summer fallow, and yes, I can enter the summer crop. So it makes that transition on that day. And then immediately, still on the 27th, it says, can I do anything more? Can I leave the wheat crop? And because the wheat crop's immature, then that's a 0, etc., etc. So you can see all of that happens on the 27th until it runs out of things to do, and then it comes back on the every day afterwards. Okay, so that detailed log, it's got every rule on every day of the simulation, sometimes several times a day. Okay, so I thought I'd do a worked example of how to add an opportunistic summer crop, and I apologise that this one doesn't make much sense because really it's a bit of a silly. We're going to make a cropping system that looks a bit like this, and I'll show you how we add the nodes and arcs, and also add a manager for that specific crop. So I'll start again from scratch so that it doesn't look so silly, and we'll say we're going to have a rotation sample. And the first thing we do is add the new component in the middle. You call it whatever we're going to call this sorghum. So you type in sorghum, give it a useful color so that you know what it is. Red, just for it. Then we add an arc from the summer fallow to the sorghum by popping up the menu here and saying add arc. We're going to configure, then add another arc from the sorghum to this other fallow, like so. So that's given us the 2 arcs. The constructing the chart is very simple, but now we need to get some logic to actually make it happen. And so the way we'll do that is we'll take our wheat manager component and turn it into a sorghum manager. And we will add a sorghum crop to the simulation too, which will be really useful. Find the crops are in here. So there's 3 crops in the simulation. We'll check that our soil can actually grow a sorghum crop. It's already got a sorghum parameterization, so we're set there. Now we can come back to the manager component. Okay, we know we've got, the manager component. We'll call it sorghum. We will call it a sorghum crop up here, and we'll sow it, say, the 15th of January to the 15th of February or whatever. We'll get the rainfall we'll leave alone. We'll give it a proper sorghum cultivar called Buster, and we'll change that from 100 plants to about 4, and that will give it a different dose spacing as well too. Okay, so that's all of a sudden we've turned that wheat manager into a sorghum manager. Let's move it up here so that looks in the right place. And now we'll start to get the coordinator to look at managing it as well too. So the rules we've got here are empty. Quite often it's simplest to copy the ones from another simulation, from another node if we've got it. So here we go, and we say summer fallow can leave, but instead of saying chickpea, we're going to say sorghum management can enter. Okay, and the action that we want to do as well is to say we're going to leave the fallow component and enter the sorghum component. So we leave there and we enter the sorghum component. Likewise, when we're leaving here, we're going to copy the rules from here. And instead of being a chickpea component, it's going to be a sorghum component. The action that we're going to do is much the same as the other one as well too. Instead of being a chickpea component, it's going to be a sorghum component, and we're going to enter the summer fallow afterwards. Done. There you go. That was it. That's how we add and manipulate the chart. Yeah. Okay. I might come back for part 2 in a little while.